Okay, for our next test, looking at chi-square. Chi-square is used when you have two nominal or ordinal variables or factor variables. So they're distinct categories, but they're not representing some underlying values like an interval or ratio variable would. The two variables that we're going to use for this are party ID, so this is people's political party, and race. So those are the two that we're going to use that are in the GSS. So first thing that I would do, check to make sure that we're dealing with nominal ordinal variables. So I'm going to use the EXPSS package and varlab this. So I want my variable labels. We'll do party ID first. That's fine. And that's telling us their political party. I'm going to copy this, just change one thing, the value label. Those are our values. So we have 0 to 7, strong Democrat, all the way up to other party. And that is clearly, like, at some level ordinal. It's really nominal because other party throws it off. But up until here, right, so from here to here is kind of in an order, if you will, but it's a nominal variable. And then race, same thing. So we're going to use variable label for race. Race right there. Okay, sorry. And the value label for race. Okay, thank you, RStudio. So it's giving us just three, white, black, other. Those are the three races that are included in the GSS. It does ethnicity as well, but those are the three. So what we have is two nominal variables, and the test when you want to compare those is chi-square. If it's just a 2 by 2, it's Fisher's exact, but we're going to do chi-square because we have more than that. I prefer to use a different package for this. So the package I generally use when I'm doing chi-square is gmodels. It does have some functionality that's really nice for doing chi-square. It's a pretty easy analysis. It's actually just called cross table. So you put in cross table right there, okay, and the structure of it is the same as most of these. Dependent variable goes first, independent variable goes second. There's not a squiggly line here, it's actually just a comma. With this, we've got these two. I'm going to assume that party ID is dependent upon race. So my dependent variable is going to be party ID. So that should go first, party ID, comma, not a squiggly line for this one. And for this one, it is going to be race. And then to get your chi-square, you actually need to add one last thing, which is expected equals true. Putting this in not only gives us expected values, which is useful, but it's going to run the chi-square calculation at the end. So once we have our code in, that's cross table, then we can actually run this, and we're going to get a big output table, right? So table's pretty big, and conveniently, it is giving us a warning message, which is going to tell us that we have to do something, which I'll explain here in a second. So in interpreting the table, this is kind of a key, right? So it tells us what we've got in here. The top is n, so this is our observed values, right? The next one is the expected values. So that would be if there is no relationship between race and party ID, what would we expect the value in that column to be? And then we have our chi-square contribution, which is useful when it comes to interpreting because it tells us how much of the chi-square is actually being contributed by that cell or that joint occurrence. Then we have our row totals. I generally prefer column totals. These are proportions. And so it's giving us a pretty good sense, right? So this is white, black, other. What proportion of the people in these categories or columns, right, fall into this group? And then here's where you can start to get an interpretation. So it's 12.5% of white individuals were strong Democrats. I'm assuming that's what that is. Yeah. Whereas 41% of black individuals were 16.2% of other race individuals. So we can already see that there's a difference. So that's how we would go ahead and interpret this, right? That's the table total at the very bottom. But, so there's our chi-square. That's useful. That's great. And it is saying that it's significant, but we have a problem. That problem right there, and this is why I like gmodels, is it's flagging it and it's saying, oh, we have an issue. One of the assumptions of chi-square is that the expected value in any given cell has to be above 5 or equal to 5 or above. And as I'm looking through here quickly, I can see an expected value right there, below 5, right? So looking through, that might be the only one. But what that means is you should probably do a recode to collapse categories or to drop some categories out. We can look really quick. So like 179 people of other races. And this is our other party, right? So not a lot of people identified as being part of another party. So a useful situation where we should probably do a recode or a subset to drop some of these people out. I'm going to go ahead and just do a quick recode and drop other party and see if that makes a difference here. So we're going to do a quick recode. We need, well, the car package, right? I use car for my recoding. You can also just call that, but we'll show you here in just a second. So I'm going to create a new variable called party ID X. So I'm creating a new variable in the data set. I'm not overriding the values in a data set. I'm using the car recode command. So this is just saying use the car package recode function in there. And what we want to recode is party ID. And this is going to tell us how we're going to recode it. So we put all the recodes in here. I'm basically leaving everything the same, except I want 7 to now equal NA. So you can actually do that and just say, leave everything the same, so if you don't mention it, it's not going to change it, but drop 7 out, because 7 is where we were running into the issues. That's the other party. So we're just going to mark them as missing, and then we can run the chi-square with everybody else. So we'll rerun it. So I'm going to run that recode. Always useful to check to make sure that your recode worked. So now there should be no 7. Yep. So we've got 0 through 6, no 7. Then I'm going to go back up and rerun this, but changing party ID to party ID X. And let's see if this works. No error down here, which means we have a minimum expected count in all of the cells of at least 5. And now we can look at our chi-square and check it. So here's my chi-square value, 222. That's my degrees of freedom, and that's my p-value. Again, scientific notation. That would be 41 zeros in front of that 8, which means this is statistically significant. Then the tricky part about chi-square is interpreting it. So chi-square is telling you, hey, there is a relationship between race, right, and people's party identification, but it doesn't tell you exactly how to interpret that. That's the part that you have to do. So you would have to look through here and see where are those differences. And like I said, the one that I find most useful for this is the column total. So right here we can again see black individuals are far more likely to be strong Democrats. And then if we go down to the other end, which would be strong Republicans, we've got 1% of black individuals, 1.3% identify as strong Republicans, whereas 11.7% identify as strong 11.7% of white individuals identify as strong Republicans. So that's what we would look for and we would report as our results. So we would say that we are 95% confident, again, alpha 0.05, that there is a statistically significant relationship between party ID and race, or race and party ID. We would report our chi-square, and then we would do our best to interpret that chi-square and where the differences are in our cross table.